In the year 2100, our children and grandchildren may live and work in the atmosphere of another world. Most of the time when we imagine the future of human habitation on other planets, it's Mars that pops to mind. But today we're going to discuss a radical notion that's Mars kind of sucks. Its low gravity would be awful for our bodies. Its lack of atmosphere is deadly, obviously, and its distance from the sun ensures a bleak existence for any future settlers. Imagine living in Antarctica, only there's no air, and there's no hope of ever leaving, and everyone gets cancer. That's colonizing Mars, and it's a bit of a tough sell. But, good news, there's a better, warmer, hipper planet, even closer to home. And it never really gets its due. And it should. That planet's Venus. It's Earth's twin celestial neighbor, which, as you'll see today, is potentially a much better candidate for future human settlements, and maybe it has been all along. So why doesn't Venus ever get the respect that it deserves? Today, let's change this and discover what life might be like in a cloud city on Venus. As far back as 1971, when the first interplanetary probes, the Soviet Venera craft, arrived at Venus, it was clear that life on the surface of the planet would never be possible. The Venera missions revealed the surface of Venus to be an inferno, with winds up to 300 kilometers per hour and temperatures hot enough to melt lead. None of the craft lasted longer than 2 hours on the surface, as each of them was crushed under the weight of 96 atmospheres of pressure. With thousands of surface volcanoes and rocked by constant quakes, the surface of Venus is one place humanity will most likely never visit in person. Yet, it is these very conditions which create some hope for a future colony on Venus, and the possibility did not escape US and Soviet planners. In 1971, Jeffrey A. Landis of NASA Glenn Research Center argued that at cloud top level, Venus is the paradise planet. Landis proposed a series of aerostat habitats, which are essentially zeppelins with breathable air inside, followed by a future floating city of platforms very similar to what was envisioned in 1980's Star Wars: The Empire Strikes Back. The Soviets, for their part, also imagined floating cities looking something like giant domed flying saucers with turbofan engines and rocket boosters where humans would be able to travel between habitats in large VTOL aircraft. The nearby sun would provide ample energy, and the Venusian atmosphere would be a rich source of essential materials for building and sustaining habitats. These platforms and habitats nestled in Venus's yellow cloud layer would provide most of the conditions for a comfortable and productive life on Venus. To understand why such a thing might be possible, it's important to know how Venus got the way it is. Billions of years ago, the sun was fainter than it is today. It's even possible that Venus was once very much like Earth, with oceans of water, continents, and maybe even life. However, by about 300 million years ago, everything began to change. The planet underwent what's called a runaway greenhouse effect. Over millions of years, the atmosphere of Venus was converted to over 96% carbon dioxide, CO2. This CO2, a greenhouse gas, trapped more and more heat. As the heat rose, air pressure on the surface also began to rise, which triggered Venus quakes, more volcanic eruptions, and more CO2 spewing into the atmosphere. By the time the dinosaurs roamed the Earth, Venus was a barren hellscape. However, because so much CO2 had been dumped into the air, the planet had developed an atmosphere over 90 times thicker than ours. This makes for relatively good conditions high in Venus's atmosphere. At an altitude of about 50 kilometers or 31 miles above the Venusian surface, pressures and temperatures reach a balance which is more conducive to life, with 75 degrees Celsius, that's 167 Fahrenheit air, and pressure about the same as Earth's sea level. Gravity is only a tiny bit lower than the Earth's at this altitude. A few more kilometers up, where the air is a little less dense and the conditions are even better, with temperatures similar to Earth. While conditions would still be extremely harsh by Earth standards, as we'll see, there are some reasons why a settlement on Venus would be much more viable than one on the surface of Mars. For one thing, it's a lot closer to Earth than Mars, up to 50% closer during certain phases of its orbit, meaning current rocket technology could reach it in just a few weeks, and a manned rocket could probably reach it in about 3 months, compared with about 7 months to Mars, according to NASA. In addition, Venus receives over 4 times as much solar radiation as Mars, meaning it would supply ample power to a potential colony. Amazingly, conditions on Venus would probably allow humans to create a kind of passive steam engine, which would simply use the ambient heat of the planet to boil water, generating all of the electricity that we'd ever need. A potential colony could also employ passive thermionic electric generators, which would produce usable electricity by taking advantage of the heat difference between the inside surface of a colony balloon or structure and the atmosphere outside. In addition, heat walls could be constructed, which could consist of long probes hanging lower into Venus's atmosphere, which a colony could use to generate electric power. That, in turn, would be used to cool the colony down. Now, like Mars, Venus lacks the critical magnetosphere that shields our bodies from solar and cosmic radiation here on Earth. But unlike Mars, its thick ionosphere provides another form of protection. This layer of highly charged particles in its upper atmosphere blocks the solar wind and solar magnetosphere from reaching a potential colony. Venus also has the critical materials like CO2 and nitrogen necessary to produce breathable air from its atmosphere. As Landis argued in the 1970s, the extremely high atmospheric pressures of Venus actually make a floating city perfectly plausible. An aerostat habitat, for example, would float just like a hot air balloon on Earth, suspended at about 50 kilometers, that's 31 miles above the Venusian surface. There would only be a tiny difference between the internal pressure and the outside, meaning that any holes or tears in the habitat would not result in sudden decompression. Rather, the gases inside would slowly diffuse with gases rushing in, making repairs fairly easy. Not only this, but the internal weight of a habitat would only really be limited by the structure's own strength. Just like a submarine in the ocean, a floating colony could maintain positive buoyancy just by reducing its internal air pressure very slightly to compensate for added mass. Paul Birch wrote in the Journal of the British Interplanetary Society in 1991 that even better conditions could be created for human inhabitants by the use of two-tiered cloud cities with an upper balloon component filled with lighter gases like helium and a lower platform component holding a human habitat at slightly above Earth sea level pressures. The added buoyancy of the upper balloon would keep the colony stable, while the lower platform components would allow humans to live and work at acceptable atmospheric pressures and temperatures. Humans on such a platform could walk outside the colony in the atmosphere without pressure-tight spacesuits, requiring only breathing equipment to supply oxygen. However, all surfaces would have to be covered in a non-reactive polymer resin to keep the Venusian sulfuric acid rains from just destroying everything. You wouldn't want to get caught in a Venusian rainstorm. Still, if an acid-proof material could be found to construct the necessary balloons and domes in which humans could live and work, platforms could be constructed that would be large enough for human settlements, replete with forests, water features, buildings, and public transport systems that all be integrated into one environment. The bigger the platform, in fact, the more stable it would actually become. There would be no risk of decompression in such a colony because the pressure differences would be extremely low and backup systems such as emergency balloons could be deployed quickly. In addition, as detailed in proposals in the USSR's own 1970s study of the concept, the Venusian atmosphere itself could be directed through giant turbofans or prop engines to navigate the colony around the Venusian sky. This would help the colony to locate the best weather conditions for its survival, even possibly choosing its own day and night cycle by flying itself around the planet at set intervals. Thanks to the extreme Venusian winds, Landis estimated that a floating city could orbit the planet in the upper atmosphere about once every 4 days, providing a day and night cycle about twice as long as that of Earth, which future humans, animals, and plants could potentially adapt themselves to. Gravity, air pressure, solar shielding, the availability of breathable gases, and a source of energy are enormous advantages that Venus provides for a potential colony. However, this by no means implies that constructing a sky city would be anything but extremely difficult. For one thing, Venus's atmosphere contains only about 0.002% water. That's about 1/200th of the average amount of water vapor in Earth's atmosphere. The missing water would be very difficult to replace, requiring either asteroid mining or a very dangerous and potentially explosive chemical process to provide it. It's not clear whether sufficient hydrogen could be found in Venus's atmosphere. It might have to be brought in from asteroid mining missions. Either way, this would also mean that dedicated platforms would be needed to generate water or use imported water to create fuel for further asteroid missions. Though here again, the abundance of energy sources in the Venusian atmosphere is a big advantage. A lot of energy is required to make fuel, and Venus has a lot of available energy. The other big problem, which we touched on earlier, is acid rain. While we do have synthetic materials such as PTFE, polytetrafluoroethylene, that could withstand the acid rains of Venus, a colony would require enormous amounts of this material to be considered viable. It would either require us to construct the habitats of these substances or to carefully coat everything from the surface of the habitat to the internal machinery, all with this acid-resistant polymer to prevent corrosion from any atmospheric gas that gets into the habitat. The problem of too much sulfur and not enough water are the major obstacles to a successful colonization efforts. However, future breakthroughs in material science and the development of asteroid mining could provide the answers here. NASA's 2015 High-Altitude Operational Concept HAVOC vehicle is an attempt to account for these problems in a potential future atmospheric mission to Venus. The first phase, a robotic exploration vehicle, 31 meters long and 8 meters tall, would be dropped into the atmosphere from an orbiting satellite and inflated in the upper atmosphere. A second mission would send astronauts with an orbital vehicle who would oversee the construction of a human habitat, mostly via robotic vehicles in the atmosphere. The third phase would see the astronauts descend into the atmosphere for just 30 Earth days in an airship about 129 meters long and 34 meters tall, similar in size to a World War II-era submarine. Taking just 100 days to reach Venus and 300 days in space to return to Earth, such a mission would be far less taxing on the health of the crew than a similar mission to Mars, where return times might be measured in years. If the astronauts NASA sends to Venus can arrive there in just 100 days, they will be far better equipped to handle the stresses of the mission under Venusian gravity than a crew that has spent over half a year in space, having experienced extreme bone and muscle density due to the lack of gravity. Phases 4 and 5 of the mission would see humans set up permanent habitations in the Venusian atmosphere. Some aerospace architects argue that the potential designs of Venusian habitats would be more friendly not only to the bodies of would-be colonists, but also to their minds. A Venusian colony, unlike one on Mars or the Moon, could be mostly constructed of transparent materials without the need for extensive pressure locks or small, confining habitat spaces. Actually, because the Venusian habitat would necessarily be much larger internally than a space station or even a Mars surface colony, these conditions would be far more suited to long-term human comfort and mental well-being. What do you think? Would you sign up for a warm, sunny cloud city on Venus, or would you rather visit the freezing, airless deserts of Mars? Let us know in the comments below. Thanks for watching.